again, Math Analyzers, and welcome to Chapter 3, Lesson 8 notes. We are going to factor by grouping. So we're big kids now. We got to look at things that have like x cubes involved, right? So, okay. Again, my usual, right? You see the notes, you have the notes. I'm not going to, read this to you like you're in kindergarten. What I am going to do is I will rewrite this particular trinomial that we're dealing with, or quadnomial that we're dealing with on here, and then go through and show you how I factor by grouping with it. So x cubed minus 5x squared plus 3x minus 15. Okay. So anything, of course, that I'm doing here is written in the notes, and you can do that at a later time. Go back and read the notes. So anything I'm doing, you know what's going on, right? So the first thing I do when factor by grouping, right, is I'm specifically looking for what can I kind of like group together where there is a common factor I can pull out of both. So it's like I'm going to take this whole 4 terms and I'm going to divide it into two term or binomials and look at them completely separately. Okay. I'm going to look at these completely separately, and hopefully what I'm looking for is having the same leftover in a binomial. Okay. That's what I'm looking for at the end, but that's depends on what these binomials look like as I'm looking at them each. So let's look at the first binomial. Okay. What do these both have in common that I can pull out? Well, they're GCF. They both have an x involved, and the lowest exponent present is a squared, so I'm going to bring out this x squared. Now I'm going to divide each of them by x squared, and let's see what the leftover is. Well, x cubed divided by x squared is x. Negative 5x squared divided by x squared. Well, the x squareds cancel out, so you're left with a negative 5. Cool. Now look at the second binomial over here. Okay, so I've got 3x minus 15, right? So what do these have in common? Well, 3 and 15 are both evenly divisible by 3, so bring that out. And then let's look at the leftover. 3x divided by 3 is x. Negative 15 divided by 3 is minus 5. And now look at what you have. The same leftover. See that? The exact same leftover. And when that's the case, what you can do is you take the front pieces of the GCF and you put those together in a binomial. Remember, that's just because I don't have the sign in front of the 3, that's a positive 3. You put these together as a binomial, and then since these were the same exact leftover, you write that binomial one time right here. This is your final answer for the factors of x cubed minus 5x squared plus 3x minus 15. Okay. That is your final answer. So this is what you do in the interim. This is the final answer. How do I know that's the final answer? I can FOIL it just to check, right? So I'm going to rewrite it down here and FOIL it separately down here and make sure that I do get those same 4 terms when I'm done. And of course, FOIL is first. So x squared times x is x cubed. Outer, x squared times negative 5 is a negative 5x squared. Inner, 3 times x is a positive 3x. And last, 3 times negative 5 is negative 15. And look at that. That's exactly the same polynomial that I started out with. Okay? So factor by grouping, we kind of treat each as its own binomial with a GCF. We're looking for them to have the same leftover so that then we can write that leftover once as a binomial in this case. Okay, so you can take these outer pieces and make them their own binomial if you have the same leftover here. Okay, it's the double distributing that you're doing with FOIL. Okay, and instead of treating them as the separate thing that you've got here, you've now combined them into one binomial for your final answer. Okay, so it's just the double distributing. That's all. It's all. It's just the double distributing. So again, I say all of that here as to how to do this, that exact example. And you can see what I did, just treat them separately. This is just reminding you that the commutative property exists for multiplication. Doesn't matter the order I write the two binomials in, the stuff inside them, that matters. So the specific things that are inside the binomials is important. Well, hey, let's get into it, right? What better way than right here where we've got more than one variable? So of course. Okay, let's grab them and separate them out. 4x squared plus 20x and negative 3xy minus 15y. Okay, let's start here. What do they have in common? We have a number and an x in common. So 4 is evenly divided into both of those, and an x can come out of each of these. Okay. 4x squared divided by 4x is a 1x left here. 20x divided by 4x is a plus 5 left here. So we're hoping for the leftover on the other side to also be a positive 5. Now this is kind of important as to how I choose to factor this next one, right? Because if I left the negatives in, I'm not necessarily going to see an x plus 5 as my binomial leftover. So instead, what I notice is, well, these are both negative. I see that they're both, we can pull a y out of both, and we can pull a 3 out of both as a factor. So what I'll do is I'll pull out a negative 3y as a factor. And what that does here is negative 3xy divided by negative 3y. Well, the negative 3's and the y's cancel, and a positive x is left, which is what I want. Negative 15 divided by negative 3 is a positive 5, and y divided by y is a 1. And so there you go. You got the same leftover when you did that. So now you take these terms and you make them their own binomial. 4x minus 3y is one binomial, and the other one binomial is x plus 5. Okay. Let's try it again. Okay, let's try that again. Over here. Okay. I'm noticing something right away. That thing I'm noticing right away is that we've got a lot of letters. I mean, yeah, that's bouncing out at me that we've got a lot of letters. The thing is, you've got to maybe move some stuff here so that you can pull a trinomial. Because if I just took these two terms together and tried to pull out a GCF, I wouldn't be able to. There is no GCF between an x squared and a positive AB. So I might have to reorder here, okay? And I'm going to choose to reorder so that, let's see, let's get an A. So let's move these two around, okay? Let's get an x squared minus ax right here. And then a plus ab minus bx. Okay, let's do that. All right. Let's try that. Let's treat this one first. Okay. What do we have here in common? Well, we have an x in common. And looks like that's about it. So now x squared divided by x is an x left over, and negative ax divided by x is a negative a left over. So really what we're saying here is our goal for the leftover on the other side is going to be an x minus a. All right. Now, as of right now, yeah, you can pull a b out of both of these. Okay. Will that leftover yield me an x minus a? Let's try it. Okay, so let's try it. Let's pull a b out of both, and let's see what we have left over. AB divided by b is a, and negative bx divided by b is negative x. Is this exactly the same leftover right now? No. And I need it to be exactly the same leftover for me to know that these two GCFs go in one binomial together. And so since I don't have exactly the same leftover, but I'm so close, right? What would make the difference here, right? If X were positive and A were negative and they were flip-flopped, we'd be good. So actually, why don't we flip-flop this? Negative BX plus AB, right? The commutative property for multiplication, let's write it in that order, and then let's get that out correctly, right? So we need this X to be positive. Let's pull out a negative B, okay? And now when you have negative BX divided by negative B, you're left with a positive X. And when you have positive AB divided by negative B, you're left with a negative A. And now you have the same leftover. So sometimes with factor by grouping, you might have to reorder your terms so that you can get the right GCF out of each term so you can have the same leftover. So now just take X minus B, excuse me, and then X minus A is the one leftover binomial that both had in common. And there is your final answer. So sometimes we're going to have to reorder so that we can even get a GCF out of our terms and have our leftover be exactly the same binomial. All right, might run into that. I think that might be the only place on in these notes, but I know you run into it on your homework once. So here, okay, let's separate them out. X cubed plus 2x squared. Okay, what do they have in common? They have an x squared in common, and we're left with x plus 2. So that's what we're hoping for on the other side. Let's see how we can get that. Negative 9x minus 18. Okay, so they're both evenly divisible by 9. I needed to pull out a negative 9, and the reason I needed to pull out as a negative 9 is because I need a positive x and a positive 2. So that does leave a positive x, and negative 18 divided by negative 9 leaves that positive 2. Okay, so now these go in the binomial together, x squared minus 9, and then these go in the binomial together. Now, what do you know about dots, difference of two squares? You know that if you see a perfect square minus a perfect square, it factors into two binomials. You can't leave dots anymore if that could factor further, because we've already talked about it in both Algebra 1 and now Algebra 2. So we need to factor this binomial one more time. The square root of x squared is x, and the square root of 9 is 3. So different signs between the two, and then bring down that other binomial. This is your final answer for factoring the original polynomial. That's your final answer. You're not allowed to leave dots anymore. You got to factor it down. When you're being asked to factor, you're factoring completely. You're getting all those factors out so we can look at them. Okay. Then over here, last one. Okay, let's treat them. Pull them over. 9x cubed plus 36x squared. All right, 9 for sure, x squared for sure. Oh boy, that's the Wolf perfect square. So let's see where this goes, right? 9x cubed divided by 9x squared, well, that's an x. 36 divided by 9, well, that's a 4. And of course, the x squareds cancel out. On the other side, okay, treat these guys as their own. So negative 4x minus 16. And they both have a 4 in common, but we need it to be a leftover of positive x and positive 4. So let's pull out a negative 4, and I see where this is going. Handwriting's on the wall about what I just finished talking about, right? Negative 4x divided by negative 4, that's a positive x left. Negative 16 divided by negative 4, that's a positive 4 left. You do have the same binomial left over, which means these two GCFs go into a binomial together. And this GCF is one binomial in the back. Perfect square minus perfect square. Okay. One more time. Bring this one down. Okay. What's the square root of 9? 3. What's the square root of x squared? X. 3x in the fronts. What's the square root of 4? 2. 2's in the backs. And different signs between them. So different signs in the middle. There you go. That is factor by grouping, my friends. Do not leave a dots alone. Always factor that down further when you're being asked to factor something. Okay? Always factor those down further when you're being asked to factor something. Remember that anytime I'm just going through straight an example that's in your notes, everything is already written out for you. So everything's already written out for you right here. You can always just go back and see exactly what I was saying each step along the way to get those particular answers. Okay. And again, I do make sure down here to state, make sure your final binomials can't factor any further. So that's what I mean by if you run into a difference of two perfect squares, make sure you're factoring that out. Okay. All right, guys. Good luck. Let me know if you have any questions, and I shall be seeing you. Remember, this is a stopping point, and we're going to have a quiz just on factoring alone, not anything else from this chapter. So we'll have a review and then our quiz that goes with just factoring. Okay. All right. Bye, guys.